We are back to do an example of an application using quadratic functions. So we are told that we have 24 feet of wood to construct 2 square gardens, and we want to know what is the minimum area of the gardens. Now, if you've ever done any type of landscaping, you might know that the amount of area we have to cover in mulch and dirt and plants is very important and determines how much money we'll need to spend. So knowing the size of our 2 square gardens will help us pretty profoundly. So as with any type of word problem, it's very helpful to start by drawing a picture. So take a moment, pause the video, and draw a picture of what our 2 square gardens might look like. So now we've got our 2 square gardens. You might notice that I didn't draw them as the same size. That's because we don't know if our 2 square gardens will be the same size or if they'll be different sizes. So we have to take into the possibility that they might be different. So let's call these side lengths of our first square x. Now, because it's a square, we know every side has side length x, and the area of the square is x squared. Then let's call the other side length y, so our area is y squared. So we know area is x squared plus y squared. And this is the equation we want to minimize. It's really hard to work with 2 variables in one equation. So it's helpful to think of what information do we have that can tell us more about what x and y may be equal to. And so if we come back to our question, we are told we have 24 feet of wood. Now all of our sides, x plus x plus x plus x, and y plus y plus y plus y, all have to add up to 24. In other words, the perimeter of each square has to be 24. So 4x plus 4y is equal to 24. In a calculus class, we would call this the constraint equation because it constrains what the area is possible. Now, I want to try to get rid of either the x or the y, because if I have both of them, it's going to be really hard to solve that equation. But I can solve the constraint equation for y. So if I subtract 4x on both sides, I have 4y is equal to 24 minus 4x. And then if I divide both sides by 4, I have y is equal to 24 divided by 4 is 6 minus x. So I can take this new form of the constraint equation and substitute it into our area function. So our area, which I'm just going to call capital A, is x squared plus 6 minus x squared. Now we can fairly quickly expand this 6 minus x squared using the formula a minus b squared is a squared minus 2ab plus b squared. This comes from our difference of squares formula. So we have 36 minus 12x plus x squared. If we carry down our other x squared, we can do some combining of like terms. So our area is 2x squared minus 12x plus 36. So we have a quadratic equation, and we want to know the minimum area. So I'm going to clear up some space here by writing this equation up a little further. So area is equal to 2x squared minus 12x plus 36. To find the minimum, we first need to know the vertex. And we can use our minus b over 2a trick to do that. So x is going to be negative b over 2a. So negative 12 is positive 12. And 2 times 2 is 4. So x is going to be 3 feet. But we need to go a little bit further because we also have to find y. So remember that y was equal to 6 minus x. And so if we plug in x, we now have y equals to 6 minus 3, which equals 3. So as it turns out, both of our squares will be the same in order to minimize the area. But we still have to actually find what the area is. So if we know our area is x squared plus y squared, then we have 3 squared plus 3 squared. So that's 9 plus 9. So our area is 18. But it's not feet, the area is square feet. So the minimum area that we're going to have is 18 square feet of garden space. To kind of summarize our process, remember we started by drawing a picture. Then we wrote equations for our area, which is what we were trying to minimize. And then we used the other information that we were given to write a constraint equation. We used our constraint equation to simplify our area equation into one with a single variable. And then we used what we know about finding the vertex of a quadratic function to help us find our final answer. And more or less, those are the steps that you can use to solve every type of quadratic function application.